equal, shear max is equal to stress max minus by stress mean divided by 2. Okay, so we know that. So why am I doing that now? Because now we have to derive, because there you have to know this. There's no what formula sheet for this. Okay, you have to know this. Okay, it's going to be a lengthy formula, but I don't want you to memorize. Okay, everything we get from the circle. Okay, so from here we have to determine what is our stress max and what is our what stress mean. Okay, so the thing to find about stress max is equal to the stress average plus by the radius of circle. And we know that the XY plane has the what? Has the largest circle, right? So from here, this will be equal to what? So this will be equal to stress X. So stress average, just look at the circle, right? So we are going to find our stress average. Okay. By the way, I don't have anything in front of me. I'm just going to derive. Okay. And in the exam, you have nothing in front of you. You are also going to derive. Are we clear? Okay. So this will have stress X plus by stress Z divided by 2. Okay. Then after that, radius of circle plus by, you have to square root. So radius of the circle is, we want to find this radius. So the only way to find this radius is you have to know what is this distance, right? So this is stress X minus by stress Z divided by 2. And you know what is this distance? This is shear XY squared. Okay. So this will be equal to stress X minus stress Z divided by 2. And then the whole thing squared plus by the shear XY squared or XZ squared. Okay. So once you have this, everything will be quite straightforward and easy now, right? So you know that the same thing for stress mean. Let me get into the other, right? So the same thing for stress mean. So it's basically equal to this whole thing, the same thing. Right? And then rather than plus, you just make sure that this is equal to what? Minus. Okay. Okay. So now you can put all your values in now. Okay. So now you put all your values in. So we know that stress max is equal to, so stress X is equal to minus 42.31 times 10 to the power 6 plus by 0, the whole thing divided by 2, plus square root by the whole thing, right? So you have 40 minus 42.31 times 10 to the power 6 plus by 0 squared, and then divided by 2, and then plus by the shear the shear is 84.621. And the whole thing squared. Okay. So from here, 42, so it's minus 21.155. Plus 42.31 power 6 divided by 2 squared plus by 84.621 power 6 squared. Square the whole thing is 87.225. So stress max is equal to 66.07 times 10 to the power 6 Pascal. And stress mean, because you already write it down, you just need to do minus. So minus 21.155 times by 6 minus by 66.07 times by 10 to the power 6. Right? So 21.155 power 6 minus 66.07 power 6 is equal to minus 87. 0.155 plus 66.07. 88. What am I doing? Sorry. Wrong number. 87.225. 55 power 6 minus by 87.225 power 6 is equal to minus 108.38 times 10 to the power 6 Pascal. Right. So now we have our what? We have our 2 points down here. Okay. Stress mean and stress max. Okay. So if we look back into our formula, right? We look back into our formula. We know that what is our normal our stress allowable, right? So we know that stress yield will be equal to stress max minus by stress mean, right? Sorry, not stress yield, our stress allowable. Okay, we call it allowable. Okay, because this is calculated. Okay. Then after that, we have to make sure that the stress allowable is less than what? Stress yield. Okay. So our stress max is equal to what? 66.07 times 10 to the power 6 minus by minus 108.38 times 10 to the power 6. Okay. So this is equal to 66.07 power 6 plus by 108.38 power 6 is equal to 174.45 times 10 to the power 6 Pascal. Okay, that's our stress allowable. So when that's the case, our factor of safety is equal to 250 times 10 to the power 6 divided by 174.45 times 10 to the power 6. Okay, so 250 divided by 174.45 is equal to 1.43. Okay. Now, if we were to do this based on tau max, right, which is equal to stress max minus by stress mean divided by 2, right? So what we have is our stress max is what? 66.07 times 10 to the power 6 minus by minus 108.38 times 10 to the power 6. And then the whole thing divided by 2. So this will be equal to 174.45 power 6 divided by 2 is equal to 87.225 times 10 to the power 6 Pascal. When that's the case, the factor of safety in terms of shear stress yield divided by your shear stress max. So this will be equal to 250 times 10 to the power 6 divided by 2, divide by 87.225 times 10 to the power 6. You realize that the answer will be the same. So 250 power 6 divided by 2, divided by 87.225 power 6 is equal to 1.43 also. Okay. So when you see this, this is also what? Tresca. Okay. But I rather write this because Tresca is in terms of what? Maximum what? Maximum. Hey, is equal to maximum shearing stress. Are we clear? Okay. So this is a good question. But again, the most important thing is what? You have to sketch. Okay. If you don't sketch, you don't know which formula to use. When I say which formula to use, you have to go back to this lecture, right over here, right? So there are two conditions, right? So the first condition, right? The first condition where you have what? Is it over here? When stress mean is equal to 0. Okay, when stress mean is equal to 0, then what will happen is where is my when stress mean is equal to 0, tau max equal to stress max divided by 2. When it's not, okay, when it's not, okay, you have to be careful. When it's not, you have to use this formula over here. Okay, you have to be very, very cautious. So review this lecture regarding what if it's equal to 0, what if it's not equal to 0. Okay, I think this is a very good revision question. Okay, it touched all components. The only thing that they don't have over here is they don't have what? Shearing stress due to shear force. That's the only thing they do. Okay. Any other questions? Yep. Because I'm not going to provide you with any formulas. I only will provide you formula how to calculate second moment of area. That's it. And also how to calculate normal stresses. Okay. The rest you have to derive from the circuit. Okay. Don't memorize. You'll go crazy. Okay. It's elastic curve on the final. No, it's not. Wait. Elastic curve. Elastic curve. No. If I test you elastic curve, you'll go crazy. Wait, let me think. No. I mean, it's not that difficult, right? Elastic curve is just integration, but you just need to know your boundary conditions, right? Any other question? Or someone pick a question. Maybe I will do it tomorrow. Anyone? Anyone like dying? Anyone that is like disturbing you? Okay, if I don't hear any question, I will stop here. Okay, tomorrow I'll be online again. Okay, if you all have any question, you can ask. Okay, I'm going to stop recording now, and I'll still stay behind if you have any question.